Hey guys, this is video 15 on accumulation functions for rate in and rate out questions, which I know you guys are pretty good at, so just keep this in mind as a review. So rate in and rate out problems involve you're given two rates, where one rate describes something that is entering and one rate describes something that is exiting. So one is coming in and one is coming out, whether that's sand being brought into a pile, whether that's people coming into an amusement park and people leaving an amusement park, whether it's water flowing into a pipe and then water leaving a pipe. These are all just situations you could have. They all involve something coming in and then something coming out. So step one, when you see these kinds of problems, they're going to give you two rates. You have to identify which one is coming in, so which one is the rate in, and which one is the rate out. So first things first, make sure you label rate in, rate out. Remember, the rate is a derivative. So if you're going to be finding an amount of something and you're going backwards from the derivative, then you're using the integral. But if you're going to be finding like the acceleration or the rate of the rate, then you're going to be finding the derivative of that rate. So in each question, identify if the question is asking you about the rate in or the rate out, or both. If it's both, subtract the rate in, rate out to put it into the same integral. Here's a pro tip. Use the unit analysis to help guide you, and store the functions into your calculator using y equals, and then use that vars function to call up the equations when using it in an integral. So if you see these questions, they usually have like ridiculous rates that you are not allowed to type over and over again. It says me. You may not type them over and over again into your calculator, so just put them into y1, put them into y2, and then you know that your y1 will be your rate in, or y2 will be your rate out, and then when you're going to use them later, you might even need y3 to say that's the rate in minus the rate out. Okay, so use those calculator tricks to help you. So what am I talking about by unit analysis? So if I know that the rate is given in like meters per second, that would mean that the rate is my first derivative, right? That means that if I need to find a total amount, or I need to find the total change, that's going to be my integral. So if I take the integral of meters per second, then that's going to be just the meters. I'm going to take off that time because I don't have a rate anymore. I have a total amount. So that would be like something in meters. And then if I take the derivative of meters per second, then I get meters per second per second. Yes, you can write it as meters per second squared, but that makes no sense. What's a second squared? So I like to write it out as meters per second per second. Just my personal preference, which means it should be your personal preference, but if you write meters per second squared, you won't be marked wrong. Alright, so unit analysis, that might really help us. Remember, we're going here for derivative and backwards for an integral. So keep in mind those tips and tricks when we're seeing these problems. Some common types of questions that you could see in these problems are, number one, how much is being put in or out? So how much, the word how much should give you a hint that that's an integral. So you're going to use the integral to find the amount for either the rate in or the rate out. They usually just have one integral, so they're usually just using one. They'll ask like how much is being put into the tank between 0 and 5 seconds. You don't use the initial condition here because I'm only asking about the amount in or the amount out. I'm not asking about the amount that's actually in the tank, right? So if I'm only asking about the amount in or the amount out, that means that you are not going to use the initial condition. Another common type of question is how much is in the tank. So now let's actually draw a tank here. So if I have a tank of water, and let's just make up a situation. I have my rate in that the water's flowing in, and I have my rate out that the water is flowing out. Okay, so now they're asking me how much is in the tank at a certain time. This is asking about the amount using the rate in and rate out, right? Because I have to take into account how much is coming in, how much is going out. So then I'm going to be subtracting my rate in minus rate out to use in my integral, because again, it's how much, so that's going to be an integral, right? And then I'm going to be subtracting my rate in, so we'll say Ri, minus my rate out. And I'm also going to be using my initial condition because I want to make sure that I'm taking into account how much water is already in the tank, right? Is the amount increasing or decreasing at time equals whatever? So in order to find out if it's increasing or decreasing, like if this water level is increasing or decreasing, it's going to depend on how much water is flowing in while how much water is flowing out. So at that time, if you can find that what the rate in is and what the rate out is, then you can subtract those two answers, and if your answer is positive, then the amount must be increasing, because that means that the rate in is more. And if the answer is negative, then the amount out is more, which means it would be decreasing. Okay, so when I'm finding is the amount increasing or decreasing at a certain time, then I'm looking for the rate in, how much is it at that time, the rate out, how much is it at that time, subtract them to see which one is going to be greater. At what time is there a minimum or maximum amount? That's another common type of question. A min and max problem, that's going to be like your optimization, right? And so when you're thinking about min and max, you're thinking about absolute min and max, you think about plugging into the original function, even though they are giving you these rates. So since I'm looking at what time there's in the tank, I'm using the whole tank, I'm definitely going to be using the rate in and the rate out function. So this question is asking about the absolute min or max. When finding an absolute min or max, you use the critical points and the endpoints, right? Because that's what we use for like an absolute max or min. And substitute into the original function. You first find the critical points using the rate in minus rate out function. So you have that integral of rate in minus rate out. Find those critical points to see what that change is. And then you're going to use your table, and you're going to have your endpoints, you're going to have your critical points here, and you're going to use that integral, this integral, to find your total amount at each time. All right, so let's try an example here. These are just some types of questions, but there could be other ones, okay? So this example is the 2003 AB2 Form B. It's about a heating oil tank. So a tank contains 125 gallons of heating oil at time equals 0. That should immediately go off in your head as, oh, that must be an initial condition because it's at time equals 0. They're telling me how much I have. During the time interval from 0 to 12 hours, heating oil is pumped into the tank at the rate of H of T equals blah, 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 blah. Gallons per hour, right? So I know this is a rate, and I'm going to label this as my rate in because it's going into the tank. During the same time interval, heating oil is removed from the tank at the rate of R of T, and this I'm going to label as my rate out because this is my another rate that is gallons per hour, right? So I know it's my rate out. Okay. Actually, you know what? Let me color code this. I'll color code it using the same colors I did in the previous page. So how many gallons, letter A, how many gallons, how many, okay, immediately I'm thinking integral, of heating oil are pumped into the tank during the time interval from 0 to 12? Okay, so let's set up this integral because I'm finding how much. If I'm finding how much and I have a derivative, I have to take the integral of that. So, and I'm finding only how much is pumped in. So I'm only going to be using that rate in. So I'm going to have the integral from 0 to 12. I want to know how much it's changing from 0 to 12. The rate in is H of T. So I'm just going to write H of T. I'm not going to write out what that actually is, which is a huge time saver and just good for notation-wise on the AP. With respect to time, I'm taking the integral. And this is straightforward, going right in my calculator. I'm going to put my H of T into Y1 in my calculator, and I'm going to put my R of T into Y2 in my calculator because I know that I'm going to be using those a lot in my problem, and I definitely don't want to be writing this out or typing it out in my calculator over and over again to save time and to make fewer mistakes. So if I do this integral in my calculator, I get 70.57085. And remember, I'm truncating after 5 decimal places. So there's my answer, 70.57085. Now be careful on these because a lot of these have like justify your answer or give a reason or explain put into it. This one does not, but make sure if it does, you make sure to explain it, right? So that's letter A. Now, letter B. Is the level of heating oil in the tank rising or falling at time equals 6 hours? Give a reason for your answer. So this is my increasing or decreasing, right? Is the level in that tank, that oil, is it increasing or is it decreasing, rising or falling? So let me get rid of this letter A so we have a little bit more room. So for letter B, I want to know, is the level rising or falling? Then I want to know how much is coming in and how much is going out, right? At time equals 6. So I'm going to find H of 6, and I'm going to find R of 6. That's going to tell me how much water, what's the rate as it's coming in at 6 hours, and what's the rate as it's coming out at 6 hours. And I'm just going to use my calculator for that because I already have them in Y1 and Y2, right? So I'm looking at my table for when H is, that's my first one for me. When H is 6, I have 5.3945. And when R is 6, when the rate is at time equals 6, then it's 8.3187. So if I subtract those two numbers, and I do my rate in minus my rate out to see which one is going to be more dominant, then I'm going to have a negative number, right? So it doesn't really matter what the number is. If you want to find it, great, you have a calculator, so that's fine. But it's going to be negative 2.9242. As long as you know it's negative, that means that the heating oil is falling. It's decreasing at time equals 6 because that means the rate out is more. Okay, so how can I write that in a nice sentence to give a reason for my answer? So I said the level of heating oil is falling at time equals 6 hours because the rate out is greater than the rate in. You can also say because H of 6 minus R of 6 is negative. Both of those answers are going to give you full credit. Okay, and this letter B is a 1-point question. Letter A was 2 points. So right now we have 3 points total on this problem. All right, next up we have letter C. How many gallons, okay, integral, of heating oil are in the tank at time equals 12 hours? So I want to know how many gallons are in the tank. Well, I have to also take into account the ones that were already there, right? So I'm definitely going to have my initial condition used here. I know that at time equals 0, there was already 125 gallons in there. And then I'm adding on how much was coming in and out, right? So the integral, what's the change? How much oil was added or subtracted between 0 and 12? Well, now which rate am I using here? I'm not just talking about the rate in, and I'm not just talking about the rate out. I'm talking about putting them together and how much is inside, right? So I need to look at the rate in minus the rate out. So I'm going to look at H of T minus R of T dt. And I should really put parentheses around this to make it more notation savvy. And this is, again, going to go right in my calculator. Remember, you put the Y1 and Y2 in there into your Y bars. So 125 plus the integral from 0 to 12 of Y1 minus Y2 dt. And remember, when you put in your calculator, you're doing it with respect to x. And my calculator is going to do pretty much all the work for me on this one. As long as I knew what to do, I'm getting a good all 3 points on this. So this is 122.02571. And I'm going to put my units on this too because I know I'm talking about how many gallons. This is 122.0251 gallons. Okay, and again, look out for those questions that say explain or justify. This one doesn't, so I'm good. I don't need to explain. I don't need to put into a sentence, but it does usually say that, so keep an eye out for that. All right, last one. Letter D. So letter D says, at what time t, for 0 less than or equal to t less than or equal to 12, is the volume of heating oil in the tank the least? Show the analysis that leads to your conclusion. So I'm looking for an absolute min, right? This is just another way to ask for that absolute min. Absolute min, you think, find the critical points, use the endpoints and the critical points, and substitute them back into the original function. So I don't have the original function, I have the rate, right? So when is that rate, h of t minus r of t, which is the rate that those gallons of oil are changing, when is it equal to 0? Well, that I'm not doing by hand. I am finding that in my calculator, so I'm going to y equals. I have my y1 and y2 already in there. So I'm just going to, in y3, I'm going to use vars y vars function. I'm going to use my y1 minus y2. So I'm not retyping anything in there. And I'm going to just remember you can turn off y1 and y2 when you graph this. I'm going to graph y1 and y2, and then I'm going to look for when does it cross the x-axis and find my zeros. And another really good tip when you're doing this, when you're graphing this on your calculator, remember that your window is from 0 to 12. So if you graph just immediately, you're going to waste some time because you're going to stare at that calculator as it graphs and graphs and graphs, but it might not be graphing the window that you need to see it on. So change your window to 0 to 12 so that you can see specifically the window and find where it crosses the x-axis. So my calculator has been graphing. I'm looking for the 0, so I went to second calculate. I'm looking for the 0. And then you do your left bound, right bound. And I see on my graph that I actually have two times that's going to hit the x-axis is going to be equal to 0. So my first one is at, I'm going to make a table here. My first one is going to be at time equals 4.790, and it has a couple more zeros after that, so I think I'm okay with 5. 4.7900, I'll put 5. 005. Okay, and that might be a good idea to store that as a number in your calculator also, so that you don't have to keep typing that in. Okay, and the second one is at time equals 11.31847. Okay, so I left a space on the top and bottom in case you didn't notice, because time equals 0 and time equals 12 also have to be tested because those are my endpoints. Okay, so at one of those points of time, that one of those is my absolute minimum. So now think about this. Is there a way to eliminate one choice without having to test anything? We're talking about a minimum. A minimum goes from negative to positive. So you're looking at the graph on your screen, right, of y1 minus y2. Is there a time when it goes from positive to negative instead of negative to positive? So it goes from positive to negative before 4.79 and then negative afterwards, which means this is going to be a maximum. Whether it's the absolute or not, it doesn't matter. That's not what they're asking me about. So I don't have to test this one. All I have to test is 0, 11.31847, and 12. If you don't realize that, it's okay. Just test it. It's just not going to be the answer. It's not a big deal. It will waste some time, but you can catch up on that time later. So if you need to test it, test it. Otherwise, just know that if you can figure out one of them is a maximum, then you know you don't have to test that one. It doesn't always work out that way. Sometimes they could both be minimums. You don't know. Okay, so now looking at my function, what was the original function? The original function is the integral of the amount in the tank, right? So I have 125 plus the integral from 0 to 12 of h of t minus r of t dt. And if I find the integral, well, now I'm not going 0 to 12, right? I want to know how much it is each time. So for my time equals 0, I have 125 plus the integral from 0 to 0 of h of t minus r of t dt, which, remember, if I'm taking the integral from 0 to 0, it's just 0, because I'm taking the integral of basically no area. So 0 plus 125 at time equals 0, it's 125, which they also told me in the initial condition, so I didn't really have to do it. And then for time equals 11.31847, I want to know, is that when it's an absolute minimum? So what is the amount that's in the tank at that time? So I want to find 125 plus the integral from 0 to that number, 11.31847. How much is in the tank at that time? That's what I'm asking. And that's h of t minus r of t dt, which when I put that in my calculator, I'm going to get 120.73818. Sorry, I can't squeeze it on there. And then remember, we already did this integral for the last one. We already did the integral from 0 to 12 plus 125. 125 plus that integral from 0 to 12. I can't get down there. But when I already did that one, I did that in part C. That was the exact thing that they asked me to do in part C, and that was going to be the answer of 122.02571. So which one is the absolute minimum? That would be at time equals 11.31847. I have to show the analysis that led to my conclusion, which I did, but I'm also going to write a nice sentence to make sure that they know that, yes, I know what I'm talking about. So the volume of heating oil in the tank is the least at time equals 11.31847 hours. And you could also add in there, so if they asked, like, what is the least amount of oil in the tank, then you would say the least amount of oil in the tank is the 120.73818 gallons, because that was at the absolute minimum. Okay? All right, so this is a pretty standard question for rate in and rate out. There are other ways to ask it. There's other things to ask, of course, but for the most part, these are like the standard generic ones. So definitely know how to do these.